So here we have, we want to find the limit of x dividing by the square root of x squared plus 1 as x approaches infinity. And so we'll let x approach infinity, then the top will go to infinity, and then this will go to infinity, and then the square root of infinity is just infinity. So we get the indeterminate form of infinity over infinity, and then we can use L'Hopital's rule. So we'll take the limit, the derivative, the top, and the bottom. So we'll do the limit, the derivative, and then this is the derivative. No, the square root of x squared plus 1 is the same as x squared plus 1 to the 1 half. So the derivative here, the top would be x. The top is 1. And then to find the derivative of this expression, then we just use the chain rule. And so it would be the exponent times x squared plus 1, and then exponent 1 half minus 1 is negative 1 half, and then we have to the chain rule, and then we have to do the derivative of x squared plus 1. So the derivative of x squared is 2x, derivative of 1 is 0, so we get 2x. One half times 2 is just 1, and this term right here has a negative exponent. If we move it to the top, then it becomes this. So if it's negative exponent here, we move it to the top, and then it becomes positive exponent, and then the bottom 1 half times 2x is just 2x. And now we allow x to run to infinity. The top, remember that power of 1 half is the same as the square root. So as x runs to infinity, right here we get infinity. And so we get infinity for the numerator, and then we get infinity, numerator again. So the first time we have infinity over infinity, and then we took the derivative of the top and the bottom, we end up with infinity over infinity. And so for this type of problem, it's just going to go round and round, meaning just infinity over infinity, over and over and over again. And so L'Hopital's rule fails here. So so to get the limit of this quantity right here, we have to use another strategy. So we need to, what we can do is divide both the top and the bottom by the square root of x squared. So divide the top by the square root of x squared, and then divide the bottom by the square root of x squared. And then we have to be careful with things like this one right here. The square root of x squared is equal technically to the absolute value of x, and this is equal to x if x is positive. So in this case, if x goes to infinity, and then the square root of x squared is equal to the absolute value of x, and this is equal to negative x. If x moves in the towards the negative direction, and so the square root of x squared is not always x. It's only is equal to x if x is moving in the positive direction, but it's equal to negative x if x moves towards the negative direction. And so this right here, this will become the top, we get x, and the square root of x squared is just x, since x is moving towards positive infinity. And then the bottom, we get, now that we have a square root divided by square root, we can combine these right here. It becomes x squared plus 1 divided by x squared. So this becomes the numerator is just 1, x divided by x is 1. And then for this part, x squared divided by x squared is 1. And then plus 1 over x squared. And so the limit of a constant 1, just 1. And here we get 1, and then as x approaches infinity, then this quantity, the quantity 1 divided by x squared, will approach 0, so we get 1 over 1, which is 1. And so the answer is 1.